Hello to everyone. My name is Frank Fillmore. I'm a principal in the Fillmore Group. We're an IBM information management, software, technology, consulting, training, and software reseller firm. The presentation today is on replication, both changes to the product packaging as well as the choices you have in terms of the technologies that you can deploy. My colleague Kim May is also on the line and can jump in as needed as we go through the presentation. We have just about an hour. We have about a third of our registered attendees online, so I'm going to go ahead and get started. I wanted to let everyone know up front that this presentation is being recorded, so it'll be viewable later. If for some reason you don't want to attend a recorded presentation, we're not going to open the lines so we can't hear you talk, so you can't say anything untoward. But just letting you know for your own for your own discretion, if you'd like to remain or not, this session is being recorded, but it will be available to your colleagues who were not able to join us today, or it could be viewed by you again at a later time. So I'm going to go ahead and proceed. Again, to communicate with me, you can either raise your hand using the GoToWebinar tool, or you can place a question in the chat. I'll do my best to keep track of the hands and the questions in line. I'll pause every couple minutes to check and make sure I haven't missed anything, and we'll allow some time for questions at the end. Our agenda today is an introduction of the Fillmore Group. Reasons to implement replication, why you might need it to solve business problems. The IBM's replication options, there's been an evolution over time, both of products that were developed internally by IBM, as well as purchases, acquisitions that they've made in the marketplace. What is really driving this webcast is sort of the central tenet of this, and that is the new single part number strategy from IBM. This was designed to reduce some confusion in the marketplace, also better enable your shops to choose the right technology to deploy for the right business case. And we're going to help you make those choices as to which tool to use in which business requirement. We're going to talk about InfoSphere Change Data Capture. We're going to talk about IBM's InfoSphere Replication Server. We'll look at some case studies, and then we'll have some time for Q&A. And I want to give credit where credit is due. Most of this presentation was developed before the single part number strategy by my colleague Kim May. She actually presented a good deal of this content at the IBM Information on Demand conference in Las Vegas in 2010. So about the Fillmore Group, we've been an IBM business partner since 1989. We've been in business since 1987, so we're celebrating our 25th anniversary. We provide technical support and consulting for DB2 and related products. We're an IBM authorized training partner, so if you want to take an IBM class on Change Data Capture or Q Replication, you can come to us at our classroom in Baltimore. We also deliver classes using the same distance learning facility that you're participating in now. We're also a software reseller, and in many cases we can save you money because we can bundle services, software, and training all in one package. Some important dates: we've been delivering education for IBM for almost 20 years now, and I've been what is known as a DB2 Gold consultant since 1998. So, some representative customers who are using replication today. So we have JP Morgan Chase. They are using QRep for a couple of different use cases. One, their very large IBM mainframe DB2 for ZOS to DB2 for ZOS customer information system, basically their retail banking operations. And we implemented this, the QRep that they're using now for their failover site that's 500 miles away from their primary data center. We implemented that in 2008. At the same time, there was a whole lot of churn and consolidation in the banking industry. They went through 2 acquisitions of Washington Mutual and Bear Stearns in that year, and we were able to increase the volume of transactions and the volume of accounts by 1/3 with no changes to the replication environment that we had put in place. Iron Mountain, we used IBM's InfoSphere Change Data Capture, and we'll talk about what these products are, what they mean, what the differences are between them in much greater detail. But ICDC we use for platform migration. Customer wanted to move their Oracle databases to a new version on a new hardware platform. They moved from Sun Solaris to HP Linux, I believe. But the keynote there is that there was no IBM footprint other than the replication technology, not IBM operating systems, not IBM hardware, and not IBM databases. But we use this technology because they're a 24/7/365 company, and they could not afford to take an outage. Their applications needed to be available. When we implemented the migration of their databases from one platform to another using ICDC, and they didn't have to take that outage. The next customer is the U.S. Federal Bureau of Investigation. One of my favorite stories about continuous availability is if the replication between the primary data center for the FBI and their hot site that's located hundreds of miles away, that link, if that queue replication is down for more than 15 minutes, the director of the FBI has to be notified. That's how crucial they see that to the national criminal justice system, which is the one that you will see on any TV crime drama. That's the one that they go and check for the automobile registrations and the licenses and the warrants and those types of things, used by local, state, and federal law enforcement agencies across the U.S. And then finally, the last representative example of how we've used QRep, we actually used a portion of Q replication known as event publishing. And the way event publishing works is instead of reading the data from a database log and then writing it to a database using SQL inserts, updates, and deletes, the way most of these examples do, we published an event, in this case, some small batch files, comma delimited files, that were then ingested by the Netezza IBM Data Warehouse Appliance. And the reason that we did it is that inserts, updates, and deletes are very slow in Netezza. It uses a batch utility in order to load data. And so we created some mini batches that were every 5 minutes populated and ingested into this system. So the Netezza Data Warehouse was only 5 minutes behind the real-time OLTP processing used for Sears.com and Kmart.com. So why do we use replication? I've given you some examples of how other companies have used it. One is to maintain production system availability 24/7. And there are a couple of reasons for that, planned and unplanned outages. Planned outages, we had one customer that was taking their system down, online e-commerce system, 3 hours per week for application upgrades and schema evolution. So for 3 hours out of the 168 hours in the week, every time a customer came to their website to spend money, they would be told to go away. There would be a splash panel and say, application unavailable, and customers would go elsewhere, and sometimes they wouldn't come back. So we needed to maintain the ability to be able to process transactions 24/7/365. Another customer, Constant Contact, is an email marketer, and they have a very sophisticated bidirectional replication environment so that you can access a server at any time because their customers are worldwide. And someone in Malaysia may want to be putting together an email campaign at 3 in the morning for the U.S., but it's prime business time for them, weekends and holidays. Disaster recovery hot site. So one of the earlier examples that I gave you was a tertiary site in an environment. Customer databases were located 14 miles apart for server failover and things like that, but for some sort of catastrophic failure, power grid failure or something like that, an earthquake, they wanted to be able to go to a third site hundreds of miles away, and replication was used for that. Database migrations, I gave you an example of Iron Mountain moving their database from one version to another, from one platform and operating system to another, without taking an outage. So we can migrate databases from one vendor to another. Another example of the way that JP Chase is using it, they used the replication technology for a migration from an Oracle database while transactions were occurring against that Oracle database to move that data to a DB2 database, which then became their system of record. Very a common use case of replication technology is to load a data warehouse with OLTP data. This is probably the first significant use case, started over 20 years ago, using products from IBM like Data Propagator Relational and using some of the Sybase replication tools. Load balancing and facilitating extended use. So instead of having one large server which contains all of my data and operating OLTP against that, I may have multiple servers and divide the transaction processing workload between them, each with a full copy of the data. And then finally, integrating data from disparate systems. So we're working with a customer right now who's looking at integrating Oracle, Sybase, SQL Server, IBM mainframe vSAM, DB2 on ZOS, all into a single operational data store. And the replication technologies that they're looking at to do this is not an in-production system at this point, but they're looking at the replication technologies that we're going to talk about today. So what is replication? When I talk about this, I've used this term over and over again. It's basically the process of copying a portion of the database from one environment to another and keeping those subsequent copies of data in sync with the original source. Changes made to the original are propagated to copies of data in the other environments. Why replication is important is that we've been moving data around since I've been in IT starting almost 35 years ago. But what we've done is we've used processes like FTP, File Transfer Protocol, which is a discrete process which takes a snapshot or a copy of a file at a certain point in time and then moves it someplace else. Now, there are two problems with the FTP approach. One is that it is a discrete process, so I have to wait until the file is fully extracted before I can begin the FTP to move it to another platform. And then I have to wait for the FTP to complete before I can ingest the data into the second database. The other is that there's no provision for keeping the data current. So once I get that bulk load of data, gigabytes or terabytes of data that I need to move into the database, all the changes that occur after the extract began are lost to the new database. It's only a snapshot in a point in time. So replication allows you to keep two data stores in sync near real time. We've seen latencies measured in 1 or 2 seconds between databases located hundreds of miles apart. So what I'm going to do right now is I'm going to do a quick check. This is a good pause for me. I don't see any questions. I don't see any hands raised. I see almost 50 people online, so I'm assuming that you're getting what you need at this point. If anything comes up, use the chat to give me a holler or raise your hand, and I will get back to you as soon as I can. So what are the IBM's replication options? First is SQL replication. This was originally known as Data Propagator Relational. It was a log-based capture system, and we'll see a diagram of how that works. And data was propagated to other systems, Oracle, Sybase, SQL Server, and DB2, of course. So this technology has been around for over 20 years. There were some scaling and some latency challenges with the approach that SQL replication took. So IBM developed in 2005 what they called Q replication. And basically what they did was they made the transport layer for Q replication WebSphere MQ. So we're using the MQ messaging system as the backbone underlying the replication, copying from the source to the target. This greatly reduced the overhead and the latency so that we can get that 1 to 2 second for very high volume transaction processing across hundreds of miles. And then the third component of IBM's three-legged stool is InfoSphere Change Data Capture. We'll refer to that as ICDC. It was an acquisition in 2007 from a company called Data Mirror. Data Mirror's heritage was on the System I, and they gathered replication data from System I and eventually from lots of other different data sources using what they called their transformation server, and replicated that data to lots of different targets. The transport layer for ICDC is pure TCP/IP. I give it a host IP address and a port number, and the data is communicated from one to the other. So we'll take a deeper dive into all three of these technically in a second. But just as you hear the terminology as we go through, SQL replication, SQL rep, QRep, also known as InfoSphere Replication Server. InfoSphere Replication Server is the packaging that you need for QRep if you're going to be replicating from or to any non-DB2 sources. DB2 sources and targets are a different animal, and we'll talk about some of those in the subsequent slides, but we refer to that as the InfoSphere Replication Server, QRep or QReplication. And then the InfoSphere Change Data Capture or ICDC. So all three of those are discrete IBM products, and they can be consumed in different ways. The big announcement in December of 2011 was the single part number strategy for all three of those components. So it was now rebranded collectively, SQL Rep, QRep, and ICDC, as IBM InfoSphere Data Replication, or IIDR. I have a link in the materials to the announcement letter, and as I mentioned earlier, there is a link, the materials that I'm presenting from now are on our blog, so you'll be able to get that link. You don't have to copy this down very quickly as I go through it, but you'll be able to click on the link and get the full announcement letter. It consolidates all three of these technologies into a single IBM part number for purchasing. It's the same price for everything, and it's $168 per PVU. So the part number is D0L34LL, meaning that if I buy this part, I get all three of these technologies. Now, why is that important? What has been happening in the marketplace is customers were being faced at purchasing time with an implementation decision. They were being asked to choose which of these disparate technologies best met their business case, and they had to do that before they acquired it, then they implemented it. What IBM has done, and quite frankly in the marketplace there was some contention, different people sold different products, so you would have two different sales reps from IBM, each pitching their own product, disparaging the other product from IBM, and so it led to a lot of confusion in the marketplace. So what IBM has done with this essentially is move an acquisition decision into an implementation decision. I know I need replication. I know I have different business use cases within my environment, some DB2 to DB2, some Oracle to SQL Server, some flat file, different types of implementation choices. Now I can say, this is the product that provides me with all that functionality, and then you can use the technology that you need for that use case. So I do see that I have a question, so let me bring that up right now. Oh, okay. Thank you very much. And no hands. So that's good. So how do you choose which is the best technology? Let's say we've decided that IBM replication technology is the one we want to go with, and I am in the process of doing an implementation. So we're going to understand specific terminology used with replication. We're going to evaluate and prioritize your replication goals, and we actually have a tool that helps you do that, a checklist that my colleague Kim put together. We're going to understand each solution's strengths. We're going to apply your product understanding to your priorities, and if at the end of the day you need some assistance with acquiring the software or implementing it, or if you need training, you can consult IBM or your IBM business partner like the Fillmore Group. So, pardon me, terminology that we use regarding replication, it's latency. This is a word that I've used, and it's not one that you use in common discussions. If you walk into a bar and you see somebody you'd like to get to know better, you don't ask, hey, how's your latency? But it is very important in the replication world. It is the time that it takes for data to get from one point in the process to another. A basic example is the time from a commit in the source database where the online transaction processing is occurring to the time that that change is committed to the target database. And again, we've seen replication latencies of between 1 and 2 seconds, even across topologies, replication environments, that are hundreds of miles apart. And so it's synonymous with delay. It could be measured in microseconds, seconds, or minutes. Source and target database. The source database is the database in which the data originally resides, is originally stored, and typically which is where some sort of activity is occurring, whether it's online transaction processing or batch loads or any sort of analytical updates. Let's say we have an actuarial process that updates assumptions, stock trades, so forth. Lots of different ways that that data can be updated. That's the source. And then the target database is where that data is replicated to, where the data lands after it's been transformed, if necessary, as part of the replication process. So we'll talk about capture and apply. A capture reads from the source database, and apply updates the target database. And we'll see graphical examples of those in a second. Talked about the transport layer. It's the methodology used to move the data from the source to target. In terms of SQL replication, the transport layer is something known as staging tables. In Q replication, the transport layer is provided by WebSphere MQ. And for InfoSphere Change Data Capture, the transport layer is provided by TCP/IP. And then finally, I mentioned the word topology before. How are my replication components arranged? So most of the examples that I've given you to this point are what we would call unidirectional, meaning that we have a source replicating to a target. We may use a bidirectional environment for load balancing, where a node, a database, is both a source and a target. So as changes get replicated to one database, transaction processing at the database to which the changes arrive, that is the target, those are then sourced to move to another database. And we'll see an example of that in a second. And then finally, peer-to-peer is basically 3 or more nodes in a topology where changes need to appear on all the nodes. We were working with the defense ministry of a European country that wanted to be able to allow for catastrophic failure of any node in the site and have 4 or 5 nodes which they could have replicating one to the other for battlefield command and still not lose any functionality. And sometimes in battlefields, catastrophic events occur. So they wanted to make sure that if any one node was taken out, they still had the resiliency to be able to recover from that and still be able to process. Let me see, I have what I believe is another question. Let me see. Okay. So let's evaluate your goals. Here are the things to consider when you are determining which replication technology to use. Number 1, are the source and target homogeneous or heterogeneous? So what I like to talk about is apples to apples, apples to pears, and apples to hamburger, because I'm mostly about food. Apples to apples are, I have a DB2 database and my target is a DB2 database. There are no transforms. I want exactly what appears in the source to land in the target during the replication. This is a very common type of load balancing or tertiary site, hot site failover topology. So that's what we mean by homogeneous. They are the same, apples to apples. Now, apples to pears mean that I may need to do some transforms of the data. I may want to do some consolidations or some summarizations. I may want to marry the data in the transaction processing system with some data from another source, and I can do that. So that's apples to pears. And then apples to hamburger is I may want to take the data out of the database and I may want to fire off a stored procedure, or I may want to create an XML document, because I may have a system of record, a transaction processing system that's proprietary that we built in our shop, but I need to feed SAP General Ledger or Oracle financials. And so I can generate from a change that occurs in my proprietary server database, I can generate an XML document that becomes a transaction against my General Ledger. So what sort of topology are we looking at? Unidirectional, bidirectional, or peer-to-peer, and we mentioned that. Speed and latency. Is there an SLA for the replication speed? How closely aligned do the server and the target need to be in terms of consistency of data? If we're in an environment where an application can run against either side, I'm doing bidirectional replication, I need that replication to be measured in the milliseconds. I need those two servers to be sharing a high bandwidth connection in the same data center. If I have a secondary or a tertiary site that are hundreds of miles away, if I have a data warehouse where I'm making analytical decisions, but I don't need to have up to the last second transaction, I have customers that accept 2-second latency. I have customers that accept 24-hour latency. As long as the target is within 24 hours of the source, they're fine with that. So you need to find out what your customer, what your business customers who are going to be using this database need in terms of their latency requirements. This is a business decision, not a technical decision. And then what is the volume of data on the source and targets? There is going to be an initial load process to get the gigabytes or terabytes from the source to the target. But more importantly than that, in choosing your replication methodology, is the transaction volume. Because on a steady state basis, what are the volume of deltas that are going to be occurring in the source that are going to get replicated to the target? Is that measured in the gigabytes or terabytes per day? We have one customer that's looking at replicating 5 terabytes a day. This is a huge amount of data, and there's certainly implications for their network bandwidth, for their placement of servers, and lots of other considerations. So be aware of that. Try to understand how much data gets changed on a daily basis. I mentioned resiliency before. How available do both the source and the target need to be? Are outages acceptable? For a data warehouse, a decision-making system, I may be able to choose to take that offline on Saturdays and Sundays for maintenance. But other situations, we have customers that say that the decision-making system, the decision support system, is as important as the transaction processing system, and decisions need to be made morning, noon, and night, 7 days a week. So the resiliency is, I need to have that system up and running, and if one node fails, I need to have another node take over. You want automated failover in terms of an unplanned outage. Working with a customer right now that is looking at several different IBM technologies, such as Tivoli System Automation, to integrate IBM's IIDR, High Availability Disaster Recovery technology, which is a DB2 to DB2 log shipping technology for high availability, with QRep to get an environment where they have 2 sites paired close together with the IIDR, and then the third site using the replication technology. There are some other questions that you need to address, such as monitoring, installation, and administration. Q replication is the fastest. I like to refer to that as the Ferrari or the jet fighter, but it uses MQ, and MQ is another technology that you need to understand. In many shops, MQ is administered outside the environment where the databases are administered. So we have the DBAs who are implementing replication. They manage the DB2, but then they're relying on another group for the QRep implementation for on MQ, and it depends on how well you're integrated with the other parts of your organization. I've seen it work really well, and I've seen a lot of delays in implementation plans because the MQ group wasn't as motivated as the DB2 group. How frequently do you change your data model? Schema evolution can be a challenge depending on the complexity of your topology, meaning that if I am adding a column to a table in one area, one table that's being replicated on the source, some of the replication technologies actually tolerate that and will replicate that new column to the target. If I need to change the length of a column, if I need to change whether or not that column accepts nulls, if I change the data type of a column, or if I want to drop columns, that becomes more complex, and there's some more procedures that are behind that that enable you to manage that. So do you do a quarterly drop of application changes, or are you changing your applications on a weekly or a daily basis? And then conflict resolution. The purpose of conflict resolution in a bi-directional or peer-to-peer environment is that I could update changes at the same time on 2 different servers, and they could collide or overlay each other. How do I decide? Will one server win? Is one server the master and the other is the subordinate? Or do I have other means of doing that with my application, or even checking timestamps and just saying the last timestamp wins? See a hand up right now. Let me see if I can take that. I thought I saw a hand up. Oh, there it is. Teresa Adubato, if you could type your question into the chat box, I'll try to address it for you. And while I see the hand. And I see a question, but I can't hear you. So the only way you'll be able to communicate your question to me is in the chat box. You should have a panel that looks like this, and you should be able to type down here and send it. Go ahead and send it to the entire audience because lots of other people probably have the same question that you do. Tell you what, while I'm waiting for Teresa to get that together, I'll take another screen or two, and then we'll get back to that. And anyone else, by the way, if you have questions, go ahead and type those into the chat box. Otherwise, we can hold the questions to the end. So the final consideration is cost, and cost is no longer a factor because with the single part number, you are getting all of the replication technology at the same price. So let's talk about each solution specifically from a technology standpoint, SQL Rep, QRep, and ICDC. Are my source and target databases supported? So we're going to look at the support that's provided by each of the replication technologies. Am I doing unidirectional, bidirectional, or peer-to-peer? Will my choice deliver the speed and latency required to meet my SLAs at the data volume that I'm anticipating if I'm moving gigabytes or terabytes of data every day? Is my selection resilient enough? Will it meet the business SLAs for availability so that as my system failures occur, disk failure, operating system failures, all sorts of bad things can happen to computers, as probably everybody on the line knows. So how do we make sure that I have another node available in the topology if my customer, my business customer says this needs to be available 24/7/365? Is my selection going to be easy enough to use for the staff supporting replication? Do I want a solution that relies on scripting to create the objects in the replication topology? Do I want a GUI interface? Which is the best for my staff, and how robust does the solution need to be in terms of administration and monitoring? So when in doubt, use the checklist. Again, this checklist is available at our blog, and just take a second and give you an example of what the checklist looks like. It's a questionnaire put together by Kim, and it allows you to rate the factors that I have discussed on a scale from 1 to 5 in terms of importance. So is low latency important? Is ease of installation, ease of use, etc.? And so there are a lot of category type questions that you can put a numerical answer to, 1 to 5. And then specific questions: how does your organization currently address high availability? Do you use a cluster technology? Are you using replication? Are you using IBM's IIDR? Are you using Tivoli's system automation, etc.? And a series of other questions that are all pretty self-explanatory as to how you would decide, how you would gather the information necessary to make an informed choice to use a particular replication technology for a particular business use case. And again, that is available on the blog site. You can download that for your use at www.thefillmoregroup.com/blog. So let's talk about some specifics of the implementation functionality. SQL Rep. The sources are DB2 on all platforms. So DB2 for Linux, Unix, Windows, DB2 for System I, DB2 for ZOS. System I being the I-Series or AS400. Oracle, SQL Server, Sybase, and Informix. The targets include all those as well. So my targets for SQL replication are everything I can get from or to. So this is a heterogeneous solution. There are some implementation specifics, and we'll talk about those on the next slide if I'm using a non-DB2 source or target. For replication within DB2 for Linux, Unix, Windows, SQL Rep is free. meaning that everything that you need in order to implement SQL replication comes with DB2 for Linux, Unix, Windows. If you have DB2 Workgroup Edition, DB2 Enterprise Server Edition, Advanced Enterprise Server Edition, and you want to replicate to another DB2 for Linux, Unix, Windows database, it's baked in there already. It is an underutilized component. I have lots of customers that invite me in to discuss their replication needs, and they say, how much is it going to cost? And I say, well, you already own the software, and they're surprised by that. The latency, all things being equal, is probably 3 times as slow as the QRep. And we'll talk about why that is architecturally in a second. It is not recommended for large transaction volumes. This is why QRep was invented, to take away some of the latency issues. It's resilient. It works with IIDR. And there is a monitoring console that's available to let you know what there is, the monitoring and alert console that allow you to manage your environment, to understand what volumes are processing through replication, whether any of your replication components are down, etc. Well, what I want to emphasize is the free for LUW. The capture component is included with DB2 for ZOS, but it requires the purchase of apply. So there is an additional software licensing fee if I'm going to be using the SQL replication technology on DB2 for ZOS. If I'm going to be replicating to other targets, such as SQL Server, Sybase, Oracle, I will have to integrate with the InfoSphere Federation Server. That does not come free. That's another separately chargeable part. So what does SQL replication look like? I'm going to use my pen. Actually, the transport layer in the middle are the staging tables. I had mentioned that before. Basically what happens is the capture component here, the capture component, reads from DB2 or IMS logs. This is DB2 on ZOS, DB2 for Linux, Unix, Windows, DB2 for iSeries. On the other hand, if I am reading from Sybase, Oracle, SQL Server, or Informix, I'm using triggers that are created in those databases to generate what the capture component needs to read in order to get these changes. So SQL replication does not natively read from the logs of Sybase, Oracle, SQL Server, and Informix. InfoSphere Change Data Capture does. So we'll talk about ICDC in a second. So if I'm going to be in a heterogeneous environment where many of my data sources are Sybase, Oracle, SQL Server, and Informix, ICDC is probably a better choice for ease of setup because it can natively read the change data in the log. Now, the staging tables in the middle are DB2 tables. So the changes are read by capture, placed in the staging tables, and then the apply component reads those changes from the staging tables and then does the insert, update, and delete into DB2, Informix, Teradata, etc. If I'm using a non-DB2 or Informix target, I need to have the InfoSphere Federation Server to be able to input the data into those targets. So I need the other component at the end sitting right here before apply. So I see a hand raised, but I still don't see anything in the chat. If you have a question, I definitely want to get to it, but go ahead and put your question in the chat box so I can see what that question is and answer it. We just decided with 50 people on the line, it would be quite a cacophony if everybody asked questions all at the same time. So I mentioned that triggers are needed when the source is not DB2. So see where it says trigger-based capture, and the InfoSphere Federation Server is needed when the target is not DB2. So that's SQL Rep. For Q replication, the sources are DB2 for ZOS and LUW. There is no support for System I. And Oracle on all platforms. So if I have DB2 for ZOS, DB2 for Linux, Unix, Windows, or Oracle as my data sources, Q replication is a good choice. The targets are DB2 for Z and LUW, Oracle, Sybase, and others with Federation. The Federation component that is necessary to write to those target databases is built into InfoSphere Replication Server. So I'd mentioned that product way early on. It's also built into the new single part number, the IIDR, the IBM InfoSphere Data Replication. Now, one of the other things that QReplication does is it can invoke stored procedures or publish XML documents. So if I want to integrate a transaction processing system with some other business process, I can do that. For example, I had a customer, a large health insurer. When a change occurred into a DB2 database, they needed to read something from a VSAM file. So VSAM is not something that's readily accessible. We had to write a COBOL program to do it. It was DB2.1z. We invoked the stored procedure that read the VSAM file, did some manipulation, and then updated data on the target. QReplication can be implemented unidirectional, bidirectional, or peer-to-peer. The latency is 3 times faster than SQL replication, recommended for very large transaction volumes, and uses MQ for the speedy delivery, uses it for assured delivery and delivery in sequence across that transport layer. Resiliency, it works with IIDR, and there is monitoring available through the QReplication dashboard. And in terms of ease of use, there is an entire scripting language, ASNCLP, which works with both QRep and with SQL Rep. So I can develop the artifacts that I need, the subscriptions that map the source to the target within a scripting language, and store that as I would DDL for a database create table statement or something like that. So I have those artifacts that I can refer back to. There is a point-and-shoot capability, a GUI interface that allows me to create these artifacts. But if I have 500 or 1,000 tables or 2,000 or 10,000, I don't want to be pointing and shooting through a GUI each time I have a table that I need to add to the topology or modification needs to occur. So what does QReplication look like? QReplication basically takes the staging tables out of the middle. I know I'm using the highlighter to circle. The QReplication uses the MQ series in place of the staging tables as the transport layer. What this enables me to do is I can get the data in an assured delivery, assured sequence fashion, so that if QApply goes to read the transactions from MQ, it knows the sequence in which the transactions have been delivered is correct and will update the target databases in sequence. Why is this important? Let's say I have referential integrity constraints on my target database. I have a foreign key pointing to a primary key. The apply component is smart enough to do those applies in sequence using what is called a dependency graph. Basically, QApply reads into memory all of the dependencies on all of the table in the target and makes decisions so that it can dispatch in a highly parallelized fashion multiple agents against the database at the same time, never getting the transactions out of sequence. So for very high volume, very complex data models, QRep is the way to go. In terms of log-based capture, here I am reading natively both from the DB2 log as well as Oracle using the log miner feature. So I have log-based capture for both. Capture reads the data from the logs, places the data on the MQ series queue, apply, reads it from the queue, and then updates the target database. Now, as I mentioned before, there's no free lunch. There is additional complexity with MQ. Typically, once you set the MQ up, it's set it and forget it. It does require, typically in most environments, coordination with SysOps, system administration folks who manage the MQ infrastructure. It is, however, the fastest and provides the lowest latency. It replicates compressed DB2 data in version 9.7. So you can reduce your log sizes and reduce the message size of the data that's being replicated. So if you have a high volume transaction processing environment and you're using compression to save on disk, QRep can support and exploit that. And there is, at this time, no support for source or target of DB2 and System I. InfoSphere Change Data Capture. ICDC supports DB2 on all platforms, and Oracle, SQL Server, Sybase, and Informix, as well as many, many others you'll see in a subsequent slide. Targets, again, are all the favorites, DB2, Oracle, SQL Server. Both relational and non-relational targets, including non-relational targets such as data stage. So I could set up log-based capture on a SQL Server database and have that data fed directly into a data stage process. Or I could place that data on a WebSphere MQ queue to be consumed by some other message broker application that I have downstream. So very sophisticated, very heterogeneous, very much apples to hamburger. Unidirectional and bidirectional replication is supported. Now in terms of latency, it's faster than SQL Rep. However, there may be some scalability issues at the very highest volumes for ICDC, and I'll show you why in a subsequent slide. In terms of resiliency, it works with IIDR for DB2. And in terms of ease of use, there is a great GUI interface which allows me to take, let's say, all of the tables in a schema and set those up as sources or targets for replication. But there is no scripting language equivalent to ASN-CLP. So if I need the scripting, if I need the artifacts, I'm better off with ASN-CLP and either SQL Rep or QRep. So this is a representative, although I don't believe complete list, of all of the sources and targets supported by ICDC. So you can see very heterogeneous. SolidDB, we actually had a customer that was replicating using ICDC from System I to DB2 Express C. We have another replication environment where the data is ending up in MySQL. So through the use of an ODBC component, we can get the data to just about any target that you need it on, as well as message queues, as well as different operating system support and different hardware platforms. So what does change data capture look like? So for a unidirectional topology from the primary data center to the backup that you can see in example 1 to something as complex as something we call a fan out, I could have the source database have transaction processing. Let's say the source is my corporate headquarters. Each of the systems to the right here are data stores that are located in each of my branch offices. And then I go through another change data capture, which allows me to deliver the data or vend the data into an ETL process like data stage or onto a message queue or some other business application. So very sophisticated source and target, very heterogeneous. So in terms of change data capture, I had mentioned its transport mechanism is TCP/IP. So in the queue replication environment, I'm using MQ as the assured delivery mechanism. I can ensure that my messages are received in the order in which they were sent. Because I'm just using TCP/IP and messages can be delivered in different sequences, pardon me, I use a bookmark to maintain where I am in the DB2 log in case of failure so that the replication process can start back up again and no data is lost. That is a small proprietary database that uses the bookmark, which must be updated in a two-phase commit with the target database updates. And we'll see a picture of this in a second. That could create a hotspot in the target at very high volumes. What is the clip point? What is the inflection point at which you ought to consider using QRep versus change data capture, all other things being equal? We don't know what it is. That's not a benchmark that IBM, I think, particularly wants to run because this just becomes fodder for competitive salespersons. However, the picture here is what the environment looks like. The log-based capture is called scraping in ICDC terms. The push engine is the capture. The capture pushes the data over to the apply engine on the target. The apply updates the application data as well as the bookmark for the metadata and does that in a two-phase commit, and the data is in sync. So we make sure that if for some reason an update either to the application data or to the bookmark fails, then the data is still consistent and we can restart from the last bookmark. So back to some of the components or pieces or considerations for ICDC. ICDC's performance is dependent on database, the bookmark database, and may constrain the volume and speed of transactions. It supports non-relational data sources such as data stage and queue. Does not require triggers on heterogeneous sources. So this is a big advantage for implementation for SQL Server and Sybase. I can use SQL Rep for those, but I have a lot more work. I have to build triggers for each different table that's being subscribed. If I'm running into hundreds or thousands of tables, I now have a whole lot of trigger maintenance that I would not have with InfoSphere Change Data Capture. In addition, it does not require the InfoSphere Federation Server for heterogeneous targets. So if I'm going to a SQL Server or a Sybase database as my target, I don't have the additional complexity of configuring the federation. So for apples to pears, from one source to a different heterogeneous target, ICDC is an important consideration. So I'm going to do a time check and I'm going to do a question check. We have about 10 minutes left, so I want to make sure that I don't see any questions in the chat. I see a couple of hands raised. Mukesh and Teresa, if you have a question, if you could enter that into the chat box, that'll give me the opportunity to respond to you. I can't, I don't have access to what it is that you want to know without that. But we'll try to get to your questions in a minute. I want to go through a couple of customer implementation examples. So a state government web portal. The customer was using DB2 Enterprise Server Edition for LUW. Both the source and target were on Z Linux LPARs within a System Z mainframe. Unidirectional replication from a portal behind a firewall in the state capital to a public portal located outside the firewall. So basically they wanted to take public information, case information, the disposition of cases and what was occurring, make that available to a web portal. They wanted to do this from the transaction processing system, which was very secure. Speed and latency were not a particular issue. If anybody's ever been to court, you know that. I hope there's nobody who is in the judicial support services for IT, but those things tend to move kind of slowly. Resiliency was not a critical issue. They were using DL1 before, and they had moved to DB2, so everything they did was an improvement. One thing that it did do by moving to DB2 was it enabled them to avoid an hour-long outage that they had taken every night for DL1 reorgs. So the DB2 itself provided that benefit, and then the replication allowed them to make that data on a near real-time basis available to attorneys and citizens as needed. Ease of use was relatively important. The Heritage Mainframe DBA staff was developing new skills for DB2 LUW at the same time that they, and Linux at the same time that they were implementing the replication. So they needed something that was fairly easy to develop and administer. And the cost, the agency had a minimal IT budget, so they used the SQL replication, which was free. Customer example for Q replication, national government located over in the Persian Gulf. For customs and immigration, the country of Qatar, QATAR, was hosting the Asia Games in 2006. And their customs and immigration systems for entry into the country were based on DB2 for ZOS. And they wanted to ensure that when all of the athletes and visitors and journalists were arriving, that there was no outage at the airport that would delay entry. If DB2 was down, people couldn't arrive, and the airport was operating at that point 24/7. So we built a bidirectional replication for warm failover between two DB2 for Z nodes that were located a few miles apart. Speed and latency were very important. the biggest consideration in this environment was the conflict detection and resolution, and we were able to work through that. Resiliency was particularly important. There was a 2-week window where they didn't want to suffer any downtime. So we needed to make sure that during high traffic periods, both systems were in sync, up, and available. Ease of use was not as important as performance, so they were willing to invest the additional time for things like MQ implementation. And the cost, this was a well-funded customer, and so they spent the dollars necessary to achieve their business goals. And then finally, the customer for ICDC, we had an appliance parts retailer. The source was in DB2 for System I. The target was DB2 Express C. I mentioned this one a little bit earlier. It was bi-directional. They wanted to be able to download to their web portal all of the different inventory for parts. If I needed to replace a gasket in a washing machine, this company Tribbles has it. I think it's www.etribbles.com. It's actually pretty amazing. It's located here in Maryland. It's one of our local companies. So if you ever have to replace washing machine, dryer, refrigerator, you name it, appliance parts, they have it. Also, in many cases, the manuals on how to do that. And they did all their transaction processing on the System I, but they needed to make this available on a web portal. At the same time, they wanted customers to be able to update information like their name and address. They didn't want people to be buying. This wasn't a pure e-commerce application, but they wanted to be able to make the data available and have the customers to be able to do search. So we use bidirectional replication to populate the OLTP to the web portal. Speed and latency, up to the second replication was not critical. If somebody bought a gasket and that did not appear in the web portal for 2 seconds, that was okay. It was important during peak web use hours for resiliency, but not a high priority. This was not an international company. They weren't looking at customers who may be operating at 3 a.m., so they had periods of lower traffic where they could take planned outages for maintenance. Ease of use was critical. This was a customer that was very much used to the System I platform, didn't want to learn a whole lot of other platforms, and had reached out to the Fillmore group and another vendor to help them develop the replication and the web portal respectively. And cost was a significant consideration. The entire budget for this was under $25K to set up the replication environment. That doesn't include the web portal, but they didn't want to spend a lot of bucks. And so for what they got, I think they got really good value. So how can I get more help? Obviously, you're welcome to reach out to me. Everybody has my email address because you've been receiving all your reminders from GoToWebinar. But it's here on this page. David Tullison is the IBM Data Replication Product Manager, and Mark Ketchy is responsible for IBM Client Technical Specialist, and all three of their email addresses are up there. If you have any questions, you want to get together with IBM or you want to get together with us about this if you have a particular business use case. And some additional resources. I mentioned PVUs before. That's processor value units. And this is how IBM prices their software based on the type of processor you have in a server and how that rates. So all things being equal, one processor will equal 100 PVUs. Certain processors that are slower may be 50 PVUs, and faster processors may be 150. So this is IBM's way of leveling the playing field. Think of it like a handicap on a golf course, so that all processors are made equal in terms of their computing power and how much IBM charges for their software. The current explanation for PVU processing for most every commercial processor on the market is located at that link. The link to the IBM replication page for the IBM InfoSphere Data Replication is there. And then IBM Developer Works has a great page, particularly for QRep, that includes an online tutorial, white papers, use cases, tools, etc. So lots of stuff that would give you a leg up if you're implementing the QRep technology.
Frank, this is Kim. There's one thing that was not included here that I just realized, is that I did not include the entire text of the IBM announcement letter or the link to it. And I'll put that up on the blog after the presentation. It is not light reading. It's actually very, very long and very cut and dry, but every single explanation of every single thing related to purchasing a replication solution from IBM is included. And so if you're getting very serious about it, it is something you should at least have available to refer to.
And I'm just going to give everybody a wonderful real-time example of latency. Watch this. As I go to this point in the presentation, as I page up slowly because it's not letting me go as fast as I'd like, I have under the slide for the single part number strategy, which is right here, I'm dragged, there it is, the December 2011 IBM announcement with the announcement letter PDF link.
Well, thank you very much.
If they download the presentation, it's, what is it, like Prego? It's in there.
It's in there.
So thank you. And that is a good point. The announcement letter is, like most IBM announcement letters, not a good read. If you suffer from insomnia, it's a good resource to have. But it is soup to nuts, everything that we described in the single part number strategy and more. So I recommend that anybody who's considering this get the announcement letter and read through it. All the considerations and caveats there that IBM usually bakes in, much more than we can go into in detail in just an hour. So at this point, I'm tempted to open up the lines. Lots of people have raised their hands, but nobody's asking me a question. So I'm going to unmute Teresa's mic. And Teresa, if you have a microphone, ask me your question now.
Yeah, this is Teresa. I am just, I was asking about WBI and how that related to MQ series, but I understand from your picture that MQ is just the delivery mechanism and that it reads the log to determine what to send over. So I think my question was answered already. Thank you.
Okay, that's very good. Yeah, I'm sorry I didn't get to it sooner. But if you feel comfortable, so you're looking at using a WebSphere broker, is that correct?
We do have WBI, and many of our transactions come through WBI today. We do also have MQ, and sometimes
so you could use a component of the replication. As a matter of fact, what I'm going to do is I'm going to get out of this and page down just really quickly. In this environment, okay, on the Q replication slide, you can use a packaging of QRep called Data Event Publisher. And basically, Data Event Publisher is everything you see here without apply. So we take apply away. So Capture reads from DB2 or Oracle, places it on an MQ series queue, and you can have whatever you want sitting at the other end of the queue. So you could have a message broker there and read from that. Alternatively, if you wanted, you could, let me see, going down to the ICDC, I could have the ICDC implementation just have as its target WebSphere MQ. So either way, if you had, let's say, SQL Server or Sybase, some non-DB2 and Oracle, because DB2 and Oracle are the only log-based sources for QRep, you could do it that way as well.
Thank you.
So any other questions? Let me see. I've gotten Teresa's question. I don't see any others. I don't see any chats. So I'm going to assume that everybody got what they needed. Again, I'll put into the chat the blog website. And that way you can download the materials and the checklist. So with that, I'm going to call it a day. Thank you again very much to my colleague Kim May for putting these materials together, doing the first presentation at IOD, and also incorporating all the information about the single part number. Take care, everyone.
Thank you.